All right, so for section 6 here, we're talking about solving now. We've got all these tools. Now we're going to apply them to equations and see if we can solve. You're really going to be dealing with two main types of equations: equations with radicals and equations with fraction exponents. But remember that those are the same, right? Radicals and fraction exponents mean the same thing. But typically, it's going to be fastest just to solve it in whatever form that they give it to you in. But you could rewrite it if you wanted to. There are two other ways you can categorize the problems we're going to be doing today. One is the problems that have just a single x on one side. So the front page of the notes, notice how if you're going through, all the ones where it's actually an equation already just have a single x. When there's only a single x and you solve, the answer you get should work. But it's always a good idea to check. Does that make sense? You can plug it in, make sure you get the right answer. If everything worked, you probably did everything correctly. But if you look at the second page, we get x's on both sides. X's on both sides of the equation often introduce extraneous solutions. We learned that term last semester. An extraneous solution is an answer that you get that doesn't actually work. So on the notes and on the homework, there's going to be some problems where it says check for extraneous solutions. On those problems, it's not just recommended that you check your answer, you have to check your answer. Does that make sense? On the test, I would just say check them all. Because it's the test. You want to get every point that you can. That's not going to tell you to check for extraneous solutions, but you should. There's probably going to be one. And if it's not, you're at least checking to make sure that the answers that you got are correct. Is everybody good there? So pay attention to the instructions, but on a test, always check for extraneous solutions. Always check your answers. On the homework, you only have to do that when it tells you to. So up here, we're going to go through essentially the same steps every time. Isolate the radical, or parentheses, you're with an exponent. You're trying to get the radical, the square root, the third root, the fourth root, or the parentheses with a power by itself. So anything that's on the outside of that, get rid of it first. Once you've done that, do the inverse of the root to undo the radical. Or use the reciprocal power. That's the same thing. Just, again, one specific example, one specific type versus the general explanation. You're undoing whatever it is, which means the reciprocal power. But sometimes we just think square root, the reciprocal power is the inverse of squaring it. Does that make sense? To undo a square root, I square it. That's kind of the simplified version of the reciprocal power. Then solve for the variable. This last part, you only have to do it on the homework when it tells you to. But again, on the test, I would always do it. Always check. So here we go. The first few are actually pretty nice. They work out really easily. Number one, does everybody see the radical here? I want that radical by itself on the side of the equal sign. So that means I need to get rid of the 5. That's easy. Subtract 5 from both sides. Minus 5, square root of 4x plus 1 equals 2. Are we okay there? So again, the idea is anything that's on the outside, if I need to get rid of a plus 5, I'm going to do the opposite of that. I'm going to subtract 5 from both sides. As long as I do it to both sides, just like any other time we're solving an equation, do the same thing to both sides, it keeps it balanced. So subtract 5 from one side, subtract 5 from the other. Now that the square root is by itself, I'm going to get rid of it by squaring both sides. Does that make sense? We haven't done maybe a whole lot of that, but it's the same as dividing both sides by a number, adding something to both sides. I can square both sides. So here, square both sides. I get 4x plus 1 equals 2 squared, or 4, right? The square root and the square cancel. And now it's a two-step equation. You've been doing these for years. Subtract 1, 4x equals 3. Divide both sides by 4. Oops. Divide both sides by 4. I get x is equal to 3/4. That is my answer. I'm done if all I'm doing is solving. Does that make sense to everybody? If you want to check your answer, you can do some extra steps to do that. You can plug it back in. So again, earlier classes had some confusion about what I'm about to do. I'm already done. I'm just plugging this in to check and make sure I got the right answer. So if I do that, I'll use a different color here to make this stand out a little bit more. When I check this, the square root of 4 times 3/4, plugging in that 3/4 right there, plus 1 plus 5 is supposed to equal 7. So 4 times 3/4, the 4's cancel out, and I get the square root of 3 plus 1 plus 5 is supposed to equal 7. The square root of 3 plus 1, that's the square root of 4. And the square root of 4 is 2. Are we all good with 2 plus 5 equaling 7? So it worked. I got the right answer. Everything's great. Yes. You can. That's what we were doing before when we were solving for a specific variable. I often don't when I'm checking because there's more of a likelihood of me making a mistake. Does that make sense? I'd rather just keep it all equal to 7 and see if this side equals 7. There's nothing wrong with that, though. It should still work. Yeah. That's fine with me. Go ahead and take the hall pass since you're in a hurry. That's, yeah. All right. Number 2. This one's even easier. First step. Anybody want to tell us what the first step is here to get the square root by itself? Subtract 3 from both sides. I would really recommend not dividing by 3 because then you have to divide everything by 3, which often we forget that plus 3 would also get divided by 3. So subtract the 3 first. So we get 3 root x equals 12. Now I would divide by 3. Does that make sense to everybody? When you're solving, solve in the opposite order of operations. Yes. No, because the 3 is on the outside. If you want to get rid of the square root before you get rid of the 3, you can. And I'm going to show you a problem like that next week. I'm recording this one, I'll upload it. You can probably figure out a lot of it on your own if you want to, but watch the video if you have any questions, and then come in and ask any questions either tomorrow or Friday. The homework is the events, just like yesterday. So here, real fast, everybody, because this is going to come up. If I squared both sides right now, everybody's full attention, because this is actually a good point. You can do this, but if I squared both sides right now, squared, I could get an answer. 12 squared would be 144. Right here's where everybody makes mistakes if they do it this way. But we practiced this, you guys. We did ones like this. Remember, the 3 gets squared also. Does that make sense to everybody? The 3 is not inside a square root. It gets squared. I'd get 9. And then the square root and square root cancel out, 9x. I could divide both sides by 9. Grab a calculator, everybody. Try that. It works out really nicely. 16 is correct. That's not the way I would normally do that one, but it would work as long as you remember that the 3 got squared. The way I would normally do this one is take the 3 root x equals 12 and divide by 3 on both sides. So that cancels out, we get the square root of x equals 4. Now this one has its own really common mistake. Please don't tell me the answer is 2, right? I have to square both sides, not square root both sides. Squared, squared, x is 16. Same thing I got the other way. You guys, as long as you use the rules that you've learned, you can solve these multiple ways. Are we okay so far? I'll zoom out a little bit too. Is that what you need? So again, you don't need to do both. I would recommend the red way. That's the normal way for solving that. But squaring a little early doesn't hurt you. Just like multiplying or dividing by 3 doesn't hurt you at the very beginning, you just have to remember to divide the 3 by 3 also. It would work. Again, as long as you're using the rules correctly, everything works. It's just some ways are easier to make mistakes than others. All right, let's try one more here. No, I want you guys to try some homework. Everybody turn in the homework to number. Let's do 1 and 2. They're real similar to what we just did. Everybody do numbers 1 and 2 right now. Give you 3 minutes. I'll put them up here as well. So do numbers 1 and 2. All right, let's go over those. And hopefully you finished one or both of them. So for the first one, step by step, let's get our answers here. First thing, what would you do first for that one? Yeah, subtract that 3 from both sides. Or root x equals 12. And then, oh, he's not here right now. Not here. Jack, what would you do next on that one? Number 1. Divide by 4. And what does that give us?
Square root of x.
There you go. And we're almost done. Yasmin, how would we finish this one? That's okay. So say that one more time. So we need to get rid of the square root right here. Well, how do I get rid of a square root? Do you want me to come back to you? Okay. Yeah. We're going to square both sides. Does that make sense? Squares and square roots are opposites. So when we square both sides, squared, squared, x is equal to 9. So Yasmin, does that make sense? Okay. Okay. So x is 9. You could plug it back in and check. It works just fine. Are we good there? Let's do the second one. Same idea. Megan, what's our first step for number 2? Add 5 to both sides. Square root of 2x plus 3 equal to 5. Not here today. Akash, what would I do next? Yes. So the square root's by itself now, so I can square both sides. 2x plus 3 equals 25. And then it's a 2-step problem. Let's finish it. Raul, what's your next step there? Subtract 3 from both sides. Minus 3, minus 3. Gets us to 2x equals 22. And then one more. Devin, what's the last step on that one? Yep. So what's your final answer, Devin? What? Should be 11 if it's 22 divided by 2. Does that make sense? X equals 11. Divided by 2. There we go. Let's jump back to the notes. And this set of notes should be this one. So I'd mentioned that we're going to come back and do some other more advanced ones next week. That's because section 9 is actually the same thing we're doing today, just slightly harder problems. It's the same kind of solving. We're just going to add a little bit to it. Now, number 3 on the notes. Number 3 has us put together our equation like we did last semester. Again, our nice reminder of how to do function notation. So function notation here, f of g of x, I'm going to put one inside the other. So that means here, x plus 3 goes inside for x there. So I'm going to write f of x in blue. F of x in blue, so 2 parenthesis to the 2/3. Inside the parenthesis, I'm putting g of x plus 3. And then that whole thing is equal to the 8 that they told us it's supposed to equal to. Is everybody good with putting together that equation right there? So now I can go ahead and let's divide both sides by 2. This time, instead of getting the root by itself, I'm getting the parentheses to a power by itself. Does that make sense? So the 2's cancel out. Over here, 8 divided by 2 is 4. So I end up with x plus 3 to the 2/3 equals 4. Once I have the parentheses to a power by itself, I can get rid of that power by raising both sides to the reciprocal. So if this is the 2/3 power, I'm going to raise both sides to the 3/2 power. That way, this gets multiplied by 3/2. This gets raised to the 3/2 power. I can cross the 3's out and the 2's out. That all simplifies, right? Does that make sense to everybody? 3's are gone, 2's are gone, left with just x plus 3 is equal to 4 to the 3/2 power. And you can simplify that however you want to. We were just simplifying a bunch of those at the beginning of class today. You can do the square root of 4. Or you could say 4 is 2 squared and then multiply it by 3/2. Let's go ahead and say, okay, this is the square root of 4 cubed. Square root of 4 would be 2. 2 cubed would be 8. So I have to simplify that. Does everybody follow those steps just like we were doing this morning, or sorry, earlier today? Maybe. You can do it that way. You can do 2 squared is 4, and then do 2 times 3/2 makes 3. Get the same answer. And now I can solve this like normal. X plus 3 equals 8. So we're going to go up here now. X plus 3 equals 8. I can subtract 3 from both sides and get x is equal to 5. So it's the same idea as what we did before, but instead of like just squaring both sides, I'm going to have to raise it to that fractional power. Are we okay there? All right. So down here to number 5, we're skipping the ones on the sides. Let's do number 5. I need to get this piece by itself, which means I'm going to add 4 to both sides. That didn't work. X plus 2 to the 4/3 equals 16. Then raise both sides to the 3/4 power. Yes. 3/4. Let's make that a little bit cleaner. You're right, that does look funny. 4. 4. Is that better? So now these, if I did it right, should all cancel. Be left with x plus 2. Over here, you can do the 4th root of 16 if you want. Or you can say, oh, 16 is 2 times 2 times 2 times 2. 2, 4, 8, 16. So 2 to the 4th power times 3/4. The 4's cancel. I get x plus 2 equals 2 cubed. 2 cubed is 8. And let's not make a silly mistake like I did this morning. I'm going to subtract 2 from both sides and say that x is 6. This morning, I did 8 minus 2 and put 4. It happens. So just need to be careful there. Everything's good. Does anyone have any questions about those steps? All right, so then on the homework, yes. So these don't tell us to. And so we're actually saying it certainly doesn't hurt to check. The ones on the back that tell us to, we have to. The trick is the way to tell whether you might need to check is if there's only one x on one side, more than likely you're not going to get extraneous solutions. It's when you have x's on both sides. That's a good check. There's actually even more to it than that. But like all the ones on here where there's just a single x, no extraneous solutions on these, as long as we do everything correct. So let's go ahead and try. I want you guys to try number 4 on the homework. Try number 4 on the homework. If you are not sure how to set up this problem, check with someone at your group. If no one at your group knows how to set it up, raise your hand and ask. Go ahead, sign up, take it back. Try number 4 on the full one. Very much like number 2. Really, really. Yes, gosh. So when you have a number to a fractional exponent, you have what? You can either write it as a radical, or you can write this number as a radical power. Which do you want to try? So take the 8 and make a factor. And hopefully, we're really hoping that they're all going to be the same number. Factor out. So rewrite that 8 as 2 to the 3rd power. 2 to the 3rd power. But then that is multiplied by the 4/3. That's since 2 to the 3rd is the 4/3, multiply those two powers. Does that make sense? So do that 3 times 4/3. And just get an answer, and you can solve for x by adding the equal sign 8 as well. And I'll do it. So in place of the x, and x, a variable, is a place to put stuff. It's like a box. So inside that x, we put x plus 3. So the original x isn't there. Sorry, Crystal. They said they had the wrong number. Are you expecting to go? Okay, we'll see if they call back in just a second. 611 is going to be. She was very confused when I said it. Okay. Yeah, perfect. Yes, it is.
Will this be posted?
What was that? All right, let me answer this question. Wait for a moment, then I'll be right there. Yes. Oh. 52 to 3. Oh, James. Yes. What was your Wait. And that's all. And if you haven't gotten your equation set up, or even if you have, you can check it up here, make sure you got the right equation, then solve that equation. And we'll go over it in one more minute. See if you can finish solving it if you haven't already. And I'll go over the next couple steps in just a second. All right, let's see what we did. First step to solve this. Bella, what would you do first to solve this? Okay, so we need to get the parentheses to a power by itself. So I need to get rid of this multiplied by 2. How do, yeah. So everybody get, we're going to divide both sides by 2. So start with that, divide by 2, divide by 2. X minus 2 to the 3/4 equals 8. Are we okay there? Yes. It should be 3/4. My 4s are just not coming out. This program likes to try to curve stuff when it's very small. It tries to smooth out what I'm writing. So 3/4 is what we want there. Now, once I got this, I need to get rid of that 3/4. Once the parentheses to a power is by itself, I need to get rid of that power. What do I raise both sides to do that? 4/3. Does that make sense? The reciprocal. Flip it upside down. So both sides raised to the 4/3. This to the 4/3. These cancel out. I get x minus 2 is equal to 8 raised to the 4/3 power. And then we've got some options for how we want to simplify this. You can take the cube root of 8. That would be fine. Or you can write that 8 as 2 to the 3rd power raised to the 4/3. And if I multiply 3 and 4/3, the 3's are going to cancel out. This actually ends up being x minus 2 equals 2 to the 4th power, or 16. Can add 2 to both sides, get x is equal to 18. There's our answer. Okay. After you've got that, go ahead and switch back to the notes. And we're going to look at some on the second page. That's not the right notes. There's the worksheet. There's the notes. So go to the second page here. This one, we have to check for extraneous solutions. And you have to remember what we did last semester. So we'll see how we do with that. Hopefully, wasn't that long ago, a little refresher, it'll be good again. Does everyone see that the square root is already by itself at this point on the left-hand side? What do you mean? Okay, for just a minute. We've got some questions for you. So as soon as you have a square root by itself on one side, you can square both sides. Squared, squared. Square root cancels out. I have an x plus 1 on this side. The trick is this other side, x minus 1 squared. Is everybody good that x minus 1 squared means x minus 1 times x minus 1? Well, we've just been doing a whole bunch of distributive properties, like on Monday, right? So hopefully we're really good at that. Let's go ahead and do the distributive property, multiply it all the way out. X times x is x squared. X times -1 is -1x. -1 times x is another -1x. And -1 times -1 is +1. Now I've got this x plus 1 over here. Just like last semester, when I see a bunch of x's and x squareds, I get everything on one side equal to 0, factor and solve. This is like unit 2 and unit 3 of last semester, okay? So now I'm gonna subtract x, subtract 1, get 0 equals x squared, -1, -2, -3, looks like -3x. And these right here, the 1 minus 1 actually cancel completely, it's gone. So in order to solve this, I need to factor it, but I don't have a third term. So instead of doing like x plus something times x plus something, I'm just going to factor out the x's. Does everybody see that they both have x's? Take an x out, 0 equals x times x minus 3. So either 0 equals x or 0 equals x minus 3. If I add 3 to both sides, I get x is equal to +3. So look at that, I got one answer, two answers. But on this side, the instructions say to check for extraneous solutions. So let's do that. Let's plug them in. Back at the very beginning. What do we got? Oh, thank you. Is it this class or?
Yeah.
Okay, perfect.
Thank you.
So you guys, if you want a calendar of events, grab one before you leave here today. Okay, I'll just leave them up there. That's what's going on this month and next month. So here, if I plug in 0, right, I got two answers, 0 and 3. If I plug in 0, the square root, let's use a different color. I'm checking my answer here. The square, no, let's use a different color than that too. Square root of 0 plus 1 is supposed to equal 0 minus 1. Square root of 1 equals -1. That is a problem. This is what happens when there's an extraneous solution from these problems. You get something like this, 1 equals -1. The reason that happens is, remember we squared both sides? What if I squared both sides right now? Does 1 squared equal -1 squared? -1 times -1 is +1. So it works for that middle step that I did, but it doesn't work for the original one. So 0 is an extraneous solution. This one's no good. Does that make sense? So we check it, we plug it in, it didn't work. Let's try 3 then. The square root of 3 plus 1 is supposed to equal 3 minus 1. Square root of 4 is supposed to equal 2. This is much better. 2 equals 2. That one's good. So I got one answer that worked, one answer that didn't. It's possible that both work. It's possible that neither of them work. Does that make sense to everybody? You just have to check. Yes, it would be. If neither of them work, you would put no solution. What if we have square roots on both sides? This one's like way easier than the last one. If you have square roots on both sides, squared, 2x equals x plus 7. The squareds just cancel the square roots out. I can subtract x from both sides and get x is equal to 7. Does that make sense to everybody? Yes. So I subtracted 2x minus 1x is just x. Now I should plug it in and check. The square root of 2 times 7 is supposed to equal the square root of 7 plus 7. Yeah, square root of 14 equals the square root of 14. We're good on that one. Last one that I want to show you, number 10. X minus 4 equals the square root of 2x. Here, square both sides to get rid of the square root. X minus 4 squared is x minus 4 times x minus 4 equal to 2x. I'm going to multiply this out real fast. I'm going to hope that you guys could do it all the way out if you needed to. But I'm just going to jump to, this is x squared minus 8x plus 16. Okay, that's what would happen if you did the distributive property. Combined like terms, that's what you'd get. Now I'm going to subtract that 2x from both sides. I need two numbers that add up to negative 10x and subtract, or sorry, multiply to 16. And yep, I already heard it. Does everybody get 8 and 2? Both negative. X minus 2, x minus 8. Maybe we're thinking over winter break, I can just shake all this knowledge out of my head from last semester. No, we need it back. We're going to keep using it every once in a while. Keep pulling on the stuff we did last time. So my answers then are x equals positive 2 and positive 8. And I need to check those. I'm pretty sure the 2 doesn't work. 2 minus 4 is supposed to equal the square root of 2 times 2. Yeah, this makes negative 2 equal 2. That's no good. That one doesn't work. But let's try the 8. 8 minus 4 is supposed to equal the square root of 2 times 8. 8 minus 4 is 4. 2 times 8 is 16. We're good. Square root of 16 does equal 4. So this one, the correct answer is 8. Yes. Yep. Right there. So at this point, you have everything you need to do the homework problems. The homework is going to be the evens again. All right. So by Friday, you should finish all the evens for 5, all the evens for 6. Friday, we're doing a quiz. It's open note, open neighbor, help each other out, ask questions. Okay. No stress on the quiz. It's a way for us to practice. You're 2/3 of the way through this unit. Okay. We've only got 3 more sections. That's going to be next week. Your test is not next week, but the week after that. So 2 weeks from today is your test. So we're taking it kind of easy as we're getting back in. Hang in there. Ask if you have questions. Come in at lunch. Come in before school, after school. If you're not sure, now is the time to get help. Not right before we get to the test. Not definitely after we do the test. Ask now. So they, I think, fixed the bells. So probably the bell's going to actually ring here in 7 minutes instead of like 9 minutes. So go ahead, get a little bit of work done here. Stay on top of it, ask some questions. I'm going to go ahead and stop the recording here.